Hi guys, this is Mrs. Spence. I thought I would give you a refresher course real quick on special right triangles. I know we discussed this in class, but I figure you might need just a little refresher by the time you got around to getting your homework done. So I'm going to show you real quick what we did in class again. If you need more instruction, still feel like you're not quite understanding, then remember, you can always Google or YouTube special right triangles. And there's 100,000 people out there that'll teach you how to do it. So try to use your resources. But anyway, let's talk about what we did in class. First of all, we're looking at the 45-45-90 triangle, trying to decide how to find the lengths of these sides. So we started out with an isosceles right triangle, obviously, because the angles here are 45, and created a square with that. Basically just to show that two of them together would make a square, and that's really the only reason I did that. But we used the Pythagorean theorem to come up with the hypotenuse, or the diagonal. And we found that the hypotenuse was 5 times the square root of 2. So we just multiplied by the square root of 2, and that was that hypotenuse. And we noticed again when we did it on this smaller square that we have again a right triangle. And keep in mind, it's a 45-45-90 triangle, that if we know the two sides, or the two legs of the right triangle, then we could easily find the hypotenuse by multiplying it by the legs by the square root of 2. And here's where we did the work to calculate the length of side C, or the hypotenuse. So then people were just saying we don't need to do all that work. All we have to do is take the length of a side and multiply it by the square root of 2, and that gives us the hypotenuse. So that was kind of nice and very easy to calculate. But until we decided we wanted to go backwards, like for example, if I give you the hypotenuse, you want to find one of the sides. So we found that we had to actually divide to go backwards. So to find the hypotenuse, you multiply by the square root of 2. To find the legs, you'll divide by the square root of 2. And we wrote that here. To go backwards, half the hypotenuse, and then multiply by the square root of 2. Oh, I'm sorry, that was a little shortcut that we found, because this is what happens. If I start out with a right triangle, and I say that this is 10, and I want to go back and find the length of this line, knowing that this is an isosceles right triangle, to find the length of this line segment, we're just going to divide by the square root of 2. And then we decided that we can't leave the square root of 2 on the bottom of that fraction, so in order to get rid of that, you rationalize the denominator. So we multiply the top and the bottom times the square root of 2, and we got 10 square root of 2 over the square root of 4, which is 2. And that actually just equals 5 square root of 2. And so this, instead of writing 10 over the square root of 2, we could just write it 5 square root of 2. So that's what I was saying about the shortcut, is you can notice that it's actually half. Instead of 10, it went down to 5 square root of 2. And then you multiply by the square root of 2, and you could easily get the length of that leg. So this also would be 5 square root of 2. So that's kind of hard to remember. Do you want to remember all that? Maybe, maybe not. It's kind of up to you. But that's one way to do it. So to summarize what we did, if you have a 45-45-90 triangle, that's referring to the angles. And of course that's an isosceles right triangle, so these would both be x. To find the hypotenuse, you are going to multiply by the square root of 2. Simple, very simple. If you're going to go backwards, like maybe we should just go ahead and generalize what happens if I give you the hypotenuse instead. To work backwards, we're going to divide by the square root of 2. Divide by the square root of 2. That's a little more work, because you have to rationalize your denominator by multiplying the top and the bottom by the square root of 2. So you have x square root of 2 over the square root of 4, which is just 2. So you can easily just take your x and multiply by the square root of 2 over 2 if you want to try to memorize that formula. But anyway, that kind of basically summarizes what happens when we have a 45, 45, 90 triangle. Alright, and then lastly, what we talked about then was the 30, 60, 90 special right triangle. Basically what we do is we create an equilateral triangle with, obviously the sides are all the same. We draw straight down the middle the altitude of the triangle, which cuts this angle in half and makes 30s. This one is a 60. So we can look at just this triangle right here and consider it, since it's a right triangle, we can use a Pythagorean theorem to figure out how long this side is right here. And so the way that looks is, since this whole side is 8 here, we know this side is 4. So we know that 4 squared plus b squared, this long side here being b, equals 8 squared. Leg squared plus leg squared equals hypotenuse squared. 16 plus b squared equals 64. B squared equals 48 when we subtract 16 from both sides. Then b is the square root of 48, which if we change that to 16 times 3, that is 4 times the square root of 3. So that makes this side right here 4 square root of 3, or the length of this side. So in just looking at this triangle, we can see that the 30, 60, 90 triangle can easily be solved. If I know the short leg, I just have to multiply by the square root of 3 to find the long leg. And if I know the short leg, all I have to do is double it to find the long leg. So we changed this one because I wanted to keep my examples all even numbers, just since we're just starting out. So we changed this to tens. So if this whole side right here is 10, then this side, this length right here would be 5. And keep in mind, this is the 60-degree angle and this is the 30-degree angle. So my short side is 5. So my long side would be 5 square root of 3. And the hypotenuse, of course, is 10. And here, if the hypotenuse is 10, then the short side would be 3. And the long side would be 3 square root of 3. So we used a pattern to be able to find out without using the Pythagorean theorem. That's the goal. We don't want to have to use the Pythagorean theorem. And really, we can't use the Pythagorean theorem all the time, because if I only give you one side, you can't use the Pythagorean theorem. You got to have two sides. So to summarize that information, if this is the 30-degree angle and this is the 60-degree angle, if I give you the short leg, then you can find the hypotenuse by doubling it. 2 times that number will give you the hypotenuse. And you can find the long leg by multiplying by the square root of 3. So that makes it fairly easy to solve, especially if I give you the short side. Now, if you're given the hypotenuse, let's call this the 30-degree angle, this the 60. If you're given a hypotenuse instead, then you're going to have to half it to find this leg, just like we did over here. This was 8, so we halved it. We found that that was 4. And then go up here to the long leg, and whatever number you get after you half it, multiply by the square root of 3. And that will give you this long side. And then, of course, the last case scenario, which in my opinion is probably the trickiest, just because you've got a little bit more to do. Here's the 30, here's the 60. If I give you the long leg, then to find this leg, you're going to have to divide by the square root of 3. And then you're going to have to double that So, which we're definitely going to have to rationalize this denominator. So let me just show a little work right here. X divided by the square root of 3. If I multiply top and bottom times the square root of 3, then I get x square root of 3 over square root of 9, which is 3. So this is actually equal to x square root of 3 over 3. So either one of these answers is really fine. This looks a little crazier. You don't want to leave it with a square root of 3, but what I'm saying is you can use either one of those to come up with the answer, and then just rationalize your denominator. And then of course, whatever answer you get there, you're going to double. So if I use this expression and double it, then I need 2x's times the square root of 3 over 3. So anyway, that hopefully helps a little bit. It's a little bit tricky, requires some practicing. But hopefully that'll help just kind of refresh your memory as to what we did and how we found all those sides. Have a good day.